looks like this. We're going to do a parent graph and then do transformations. Here goes. The negative sign out front, reflect through the x-axis. We'll take about time on these review problems. 9 subtract x. By this time you know that should be turned around. The x should come first. That's no problem. I'll turn it around. But then an additional problem would be, who recalls?
Also reflects through.
Who recalls at this point, just simplify it a little bit before I do the transformation. You gotta take the negative sign out and make it look like that. Or that's gonna throw the transformations off. That's gonna make the transformations off. So guys, 9 subtract x will be expressed like this. Now Lisa, you might be trying to tell me now, what now can I say? The negative sign that I do have out front tells me what should I do there in terms of the transformation. Reflect through the y-axis. This is a beautiful example. See if I have the markers here. Try black. The x subtract 9 in beautiful form. That's a horizontal shift to the right. Nine units when I get to it. I'll do that in black. Finally, what I have left here.
2 units.
Hang on. I'm trying to come up with color here. Subtract 2. A vertical shift down 2. Right. One of these green markers will work. Guys, watch carefully on this problem. Vertical shift down 2 units. Loads of partial credit here. Now I need to follow those transformations in those different colors and do it. I think, Aiden, did you and I look at this one?
Yeah.
Here goes, guys. Draw the grid. We'll do the best we can here. Now, first need a parent graph representing a log. They basically take the same shape. So guys, a parent graph will have an x-intercept at 1. It's going to look something like, got for me something like this as a shape. So this represents a parent graph, in this case log base 3x. All the logs look like that, basically. By the way, if this were an exponential, e to the x, 10 to the x, 3 to the x, what would a parent graph for an exponential look like? It's up here doing this. For a y-intercept at 1. Okay, they are in versus 1. The log always looks like this, on the log. Now, let's do the red. Reflect that through the x-axis, no problem. Flip it across the x-axis. It's got to take a shape, something like that. I'll label as I move along. Then I'll get out of my way and get out of my student's way here so you can see it. Looks like that. Partial credit. Next, it says in the orange, now reflect that red through the y-axis. No problem. I'm going to call this -1. As I flip that through the y-axis, please tell me, does it look like that? Is that true? The red reflected across the y-axis, does it? Does it look like that? I hope so. If so, we now have this. I'll label it for you. That's what the orange represents. Next, and the blue, black, In the black, horizontally shift this, whoo, hang on, 9 to the right. Okay, so take that orange graph and horizontally shift it 9 to the right. By the way, this point right here is at -1. I know if I shift it, it's going to land at what, 8? Okay, so out here at 8. Put it out here, guys. That would be that point. Shift it 9 to the right. As I shift, I better not forget there's an asymptote to shift. The y-axis is the vertical asymptote. Shift it 9 to the right. It's out here. It stretches out somewhat. And it is now here. Now, is that enough to get what I want? Please tell me, guys, based on that orange graph. Am I saying it now? It looks like this. The orange has been shifted to the right 9 units. That makes sense? The black is to the right of the orange. 9 units. Woo! My last transformation is vertical shift down 2. And guys, I know and you know, where am I? Don't need to mess up here. I could go ahead and shift this down 2. All right, this point right here, on the black graph, I know if I shift it down 2, it would help. Down here, now I'm doing this in green, so if I say, well, I'm going to shift everything down 2, Professor, this point must be down here on your final graph. Making sense? Now, what else have I always asked you to find? The intercepts on the final graph. Now, this is where you got to be careful. I mean, extra careful. So, guys, in the green here, I need to find the x-intercept, the y-intercept. To find the x-intercept, you know by now to go back and set that function equal to 0, which looks crazy when you do it. It looks like this. Now, you might, as a student, have difficulty solving that. I hope you don't. You've got to solve it for x. Any suggestions on what you would do first in the attempt to get the x? Add 3, or add 2. Move the 2 over. Move the 2 over. Now watch carefully, because this is the part I'm concerned about. Now, would any student now suggest what you might do next in your solving?
Divide by 1.
That's him again.
Divide by -1.
Divide by negative. I don't like that negative. So divide both sides by negative to make this -2. And now the negative's gone, which looks much better. Now it looks like that. Now, no more across the street algebra. To finish this up, someone's going to tell me at this point, what does that statement mean? And I'll write it out. It's not algebra. You got to tell me, what does that statement staring at me right here in the green, what does it mean? And that's going to throw you. Who has no idea what it means? Yes?
3 to the power of -2.
Look, hold on. 3 raised to the power of -2. 2 more.
Equals 9.
Look at that. Mathematician. That's exactly what that means. The word log's gone. That's what it means. Now I can solve it. From across the street. 3 raised to a -2, guys, real quickly, I'm gonna call that 1/9. I think you would also. 9 subtract x. Is that true? Is it 1/9? 3 raised to a -2. To find the x, you can move things around the best way you want to. I don't care how you do it, as long as you get the x by itself. I'm gonna move the x to the left and subtract 1/9, make it move to the right. That's up to you though. Let's move things around. So guys, this right here would be, I'm gonna do it quickly, that's 8 and 8/9. Or you could do a common denominator. Express it as a fraction. I think it's 8 and 8/9. 9 subtract 1/9. 8 and 8/9. Is it 80 over 9?
Yeah.
That's beautiful. Here we go. Beautiful. That is what I think you and I said earlier, right? Now, since I have expressed as 8 8/9, I now know where to place it. The x-intercept is just a little to the right of this 8. It's right here. Just a little to the right of 8. 8 8/9. I don't have the y-intercept yet.
Yeah.
The y-intercept, to find the y-intercept, you're supposed to find what? F at 0. Replace all those x's by 0. And here we go. End up with negative log of the base 3. Nice. 9 subtract 0, subtract 2. Step back and look at it. I'll replace the x by 0. Calculation, negative log base 3. Guys, this is really 9. And I hope everyone in class knows that.
It's 2.
Log of 9 base 3 is 2. 3 squared equals 9. I had a negative sign in front of it.
Negative 2,
Negative 2 and negative 2 gives me all together.
negative 4.
Thank you. So my y-intercept is down here at negative 4. I can mark it. It is here, put it in green. And after all that discussion, connect my green points, and I have it to look something like this. There's your answer. There's your answer. I hope I can do those okay. You know, guys, I don't think I messed up. Does it look good? David, look good? There's the answer. That's the graph. Now, can someone tell me what is the domain on that green graph?
From negative 0.
From left to right. The negative infinity goes from that way, swooping that way, right? The negative infinity over to, we'll stop at 9. There's an asymptote there.
Yeah.
Negative infinity over to 9. The range, I heard it, the up and down,
Negative.
negative infinity through positive infinity. Wow. If I ask you where is my function less than 0, translate, when is it below the x-axis? It's below the x-axis right here. Can someone describe that for me? Negative infinity over 2? What was that x-intercept?
8.
8
8
over 9.
Where I lost on my track here. Right, 8 8/9? So it's a negative infinity, here we go, over to 8 and 8/9. Wow, it's below the x-axis. This piece right here. I can answer questions like that.
Oh, that would be.
That's a little sketch, and you know you have a sketch on the exam. Will yours look something like this?